Welcome you all. Welcome my friends. I am Dr. Arup Chattopadhyay from Mathematics Department, IIT Guwahati. This time I am going to offer a new NPTEL MOOC course, namely Complex Analysis 1. The course is designed mainly for master students who are in first year and they completed their real analysis in the first semester, and also the course is designed for advanced undergraduate students. Currently they are in second year, that means they completed first year like calculus courses, and also the course is designed for first year PhD students for their coursework. Now complex analysis is a very vast subject. In fact, I should say that complex analysis is one of the fundamental subjects in mathematics that is introduced in undergraduate and postgraduate level in mathematical sciences, engineering sciences and technological sciences. Now, if you look at the syllabus of this course, you will see this course contains the syllabus of NET exams and GATE exams. So, therefore, it is expected that the students from master's background, for them it will be very much useful for this course, and also for advanced undergraduate students who are interested in higher mathematics and wanted to qualify like GATE and NET, for them also it will be very much useful. And also I should say that this course also very much useful for engineering background students, particularly the students who are from mechanical engineering or electrical engineering. Why I am saying like these things? Because you see, complex analysis contains very powerful and beautiful techniques that is not available in real analysis, and the students from engineering background sometimes they need to evaluate kind of integrations like some indefinite integral or improper integral, and whatever techniques available in real analysis, that is not possible. So, using the techniques available in complex analysis, they will be able to solve those kind of problems. And of course, complex analysis has very much applications, couple of applications I will talk about in my course. So, I am pretty sure the students like from a master's program or undergraduate program and also like the first year PhD students, they will get benefited from this course. So, that's like very brief about this course. Now, let me just talk about the outline of this course. So, this course is a 12-week course. So, in the first week I will talk about like review of complex numbers, and then I will talk about limit, continuity and differentiability, and of course I will give the connections, what is the connections between real differentiability, or what is the difference between real differentiability and complex differentiability. And then in week 2 I will introduce the notions of analyticity, Cauchy-Riemann equations, give like necessary and sufficient conditions for analyticity, but you know that necessary and sufficient condition for differentiability in real analysis case. So, similar kind of like concepts I will talk about. Then I will introduce the notions of what is called harmonic functions. I will talk about how to calculate harmonic conjugate, and then I will move my discussions in what is called integrations. I will talk about what is Riemann-Stieltjes integral, very brief about that. Then I will introduce the concept of what is called contour integrations. Then very beautiful theorems will come like Cauchy-Gusset theorem, and then week 4 I will talk about, as I said, very beautiful theorem like Cauchy's integral formula, Cauchy's estimates, Liouville's theorem, Morera's theorem. So, these are the very beautiful theorems in complex analysis. Then in week 5 I will move my discussions like to talk about fundamental theorem of algebra, maximum modulus theorem and Schwarz lemma. Okay. Week 6 I will talk about what is called power series, the notions of power series, and then I will discuss the connections between analyticity and power series. Okay. And then in week 7 I will talk about what is called zeros and singularities of analytic functions, and then I will talk about classifications of singularities. Okay. And again couple of very beautiful theorems like open mapping theorems, and then I will introduce the notions of what is called meromorphic functions. Week 8 I will talk about again couple of beautiful theorems like Lorentz theorem, Cassaroli-Weierstrass theorem, argument principle, Rauch's theorem. And as I said in week 9, as I said, couple of beautiful powerful techniques available in complex analysis like Cauchy's residue theorem, because I already discussed singularity. So, therefore, I am in a position to talk about Cauchy's residue theorem. Once I have Cauchy's residue theorem, then I will talk about how to evaluate various kind of integrations using Cauchy's residue theorem. So, like for example, I will discuss evaluate definite integrals of trigonometric functions, evaluating improper integrals of rational functions, and then evaluating improper integrals transform Fourier analysis. Again, in week 10 I will give some kind of another type of integration, that's called indented contour integrations, indentations around a branch point, indentations around a branch cut, and then as an applications I will talk about what is called finding the inverse Laplace transform using what is called Cauchy's residue theorem. And week 11 I will move my discussion to conformal mapping and Mobius transformations, and a couple of these applications I will discuss. And in the last week I will talk about again two beautiful theorems. So one of them is like Riemann mapping theorem and Weierstrass factorization theorem. So that's all very brief about this course. So I believe that the students who are going to attend or credit this course will be benefited, particularly the master students or advanced undergraduate students, those who are interested in higher mathematics or advanced complex analysis or in number theory or interested in PhD program. For them it will be very much useful because it contains the syllabus of NET and GATE. So I believe that it will be very much useful for those students. So that's all from my side. We will meet in week 1. Thank you.